I have a dream, that's all I need. I'll make it happen with some work and belief. Know what I want, so I'll take.
Hi guys, what's up? Welcome back to my YouTube channel, Math-maticTV. So today we're going to continue our topic about differential equations. So now I'm going to discuss the elimination of arbitrary constant. So how do you understand elimination of arbitrary constant? So, example, if we have a problem for number 1, y equal to c1 e raised to negative 2x, then plus c2 e raised to 3x. So, how can we know the arbitrary constant? So, since we have a problem or problem y equal to c1 e raised to negative 2x plus c2 e raised to 3x. So this is the general solution for such a differential equation. Example, if we're going to solve for the general solution of such a differential equation, so this will be the answer. So elimination of arbitrary constant means that we need to find the original differential equations that will give the answer like this. This is the same as this is like integral and derivative. So if we're going to integrate sine x, this will give negative cosine x. Now, so this is the answer for this integral. Now, if we're going to differentiate this negative cosine x, it will give us sine x. So this is the same, or this like this. So the problem is, how can we determine the differential equation problem, or the given differential equation that will give us the answer y equal to a e raised to negative 2x plus b e raised to 3x, or the same as c1 e raised to negative 2x plus c2 e raised to 3x. So for me, I can easily get the problem or the differential equation problem that will give the answer y equal to c1 e raised to 2x, or e raised to c1, or c1 e raised to negative 2x plus c2 e raised to 3x by since I know the undetermined coefficients. So the roots of this general solution, which is negative 2 and 3, so since m equal to negative 2 and 3, therefore m minus 2 or m plus 2 times m minus 3 equal to 0. So this is the roots. So m squared minus m then minus 6 equal to 0. Hence our differential equation will be y double prime minus y prime minus 6 equal to 0. Now if we're going to solve the general solution for this given differential equation, this will be the result, or we will end in the answer y equal to c1 e raised to 2x plus c2 e raised to 3x. But today I will show the proper approach to get the differential equation problem that will give the answer c1 e raised to 2x plus c2 e raised to 3x, or I will show how to eliminate arbitrary constant. First, we need to get the first derivative of this problem, which is y prime equal to negative 2c1 e raised to negative 2x, then plus 3c2 e raised to 3x. So then I will get the second derivative, which is y double prime equal to negative 2 times negative 2, this will become 4, then c1 e raised to negative 2x, then plus 3 times 3, which is 9, c2 e raised to 3x. Now I will eliminate this, or yes, I will eliminate these two, the y prime, and let this let's say this will be our equation 1, this will be our equation 2, and this will be our equation 3. So I will add the equation 1 and equation 2. So this will become y equal to c1 e raised to negative 2x plus c2 e raised to 3x, then plus y prime equal to a negative 2c1 e raised to negative 2x plus 3c2 e raised to 3x. So how can eliminate c1 and c2 or a and b? So I can eliminate c2 by simply multiplying both sides by negative 3. So this will become negative 3c2. Now if I'm going to add these two, this will be cancelled. I can also eliminate c1 by simply multiplying both sides by 2. Then if I will add this will be cancelled. So I will multiply both sides by 2. So we will end in 2y equal to 2c1 e raised to negative 2x plus 2c2 e raised to 3x, then plus y prime equal to negative 2c1 e raised to negative 2x plus 2c2 e raised to, this is 3 rather, so e raised to 3x. Hence, if I'm going to add these two, this will be cancelled. So 2y plus y prime, so this will become y prime plus 2y equal to, since this will be cancelled, 2c2 e raised to 3x plus 3c2 e raised to 3x, so this will become equal to 5c2 e raised to 3x. Now I will equate or add equation 1 and equation 3. So this will become, let's say this will be equation 4. So now I'm going to add equation 3 and equation 1. So y equal to c1 e raised to negative 2x plus c2 e raised to 3x plus y double prime equal to 4c1 e raised to negative 2x plus 9c2 e raised to 3x. So again, I can eliminate c2 by simply multiplying both sides by negative 9, and I can also eliminate c1 by multiplying both sides by negative 4. So if I'm going to multiply both sides by negative 4 times negative 4, so this will become 4y equal to, this is supposed to be negative since this is negative, negative 4c1 e raised to negative 2x plus this is supposed to be minus now, since negative times positive is negative, then minus 4c2 e raised to 3x, and I'm going to add y double prime equal to 4c1 e raised to negative 3x minus, or plus rather, plus 9 c2 e raised to 3x. So I will just erase these two, so we will have a space. Now if I'm going to add these two equations, this will become y double prime minus 4y, y double prime minus 4y equal to, since this will be cancelled or c1 will be cancelled, so 4c2 e raised to 3x plus 9c2 e raised to 3x. So this will become subtract, or I will subtract negative 4 to 9. Yes, I will subtract 9 to 4. So this will become 9 minus 4 equal to 5 c2 e raised to 3x. Now have equation 5. So the last thing we need to do is equate equation 4 and equation 5. Since 5c to e raised 3x is equal to y double prime minus 4y, and 5c to e raised to 3x in equation 1 is equal to y prime plus 2y. So since we have a value of 5c to e raised to 3x, I will just equate this. So this will become y prime plus 2y equal to 5c to e raised to 3x, which is here. So y double prime minus 4y. Hence, our general solution will be, or the differential equation will be y double prime minus, I will transpose this to the right side, so this will become minus y prime, and I will transpose also 2y into the left side, so this will become minus 4y equal to 0. So this is the same for what I get earlier when I introduced this problem. Hence, this is the given differential equation that will give the general solution y equal to c1 minus 2x plus c2 e raised to 3x. Alright, let's proceed to the second example. X minus a squared plus y squared equal to a squared. So this is a squared. Remember that a is just a constant. This is x. So again, we need to get the derivative both sides. So this will become 2, then x minus a using chain rule, then plus 2y y prime equal to 0. And I will distribute the 2, so this will become 2x minus 2a plus 2y y prime equal to 0. I can divide both sides by 2, so this will become x minus a plus y prime equal to 0. And hence, we have a value of a now, or we can get a value of a now by simply transposing to the left side all the given value, or I can transpose a to the right side. So this will become x plus y prime equal to a. Now since we have a value of a, we can plug in this value into the equation, so we can get the differential equation. So since we have a value of a, this will become x minus x plus y prime squared plus y squared equal to, we're going to square this, so this will become x plus y prime squared. So since we already substitute the value of a, so this will become x minus x y prime is supposed to be minus, since we distribute the value of x. So x times x, this will become x squared. X squared minus x y prime, yes, y prime squared plus y squared equal to x plus y prime squared. So I can factor out the x here. So this will become x times oh my bad, this will be back to the so now I will substitute the value of a, since we have a value of a now. So I will substitute to the equation here, which is x minus a squared, or x minus a raised to 2 plus y squared equal to a squared. So this will become x minus x plus negative times, this is supposed to be negative y prime squared plus y squared equal to x plus y prime raised to 2. Now this will be cancelled and we need to square the y prime. So this will become y prime squared plus y squared equal to x squared plus 2x y prime then plus y prime squared. And hence this will become, if I'm going to transpose y prime to the left side, this will be cancelled. So y squared equal to x squared plus 2x y prime. And hence our general, or the given differential equation will be y squared minus x squared minus 2xy prime equal to 0. And if we're going to get the general solution for this, we will end in x minus a raised to 2 plus y squared equal to a squared. Since a is just a constant. Alright, that's all for today, guys. Thank you so much for watching, and please share your thoughts about it by commenting below. And if you learned something today, please give this video a thumbs up. Also, if you want to see the other videos, link in the description below. And please don't forget to subscribe and click the notification bell. Stay tuned and see you on my next video. Thanks and God bless.
I have a dream, that's all I need. I'll make it happen with some work and belief. Know what I want, so I'll take it on. I've made mistakes, but mistakes make you strong.